Welcome to H2K Infosys. H2K Infosys is a e-verify business based in Atlanta, Georgia, United States. We provide 100% job-oriented, instructor-led, face-to-face, true live online software training programs. It also includes access to cloud test lab with software tools. We provide live project for you to work on. We also provide assistance with mock interviews, resume preparation and review, and job placement assistance. H2K Infosys is trusted by so many students across the world. H2K Infosys provides world-class services in IT training with real-time project work for corporates and individuals, special IT training for MS students in the United States, software design, development, QA manual and automation, performance testing and maintenance, IT staff augmentation, job placement assistance, and tech support.
We have started both the threads. Even though if you specify the main thread to join the call stack of FTE, but still one another thread is in the memory, which is in the running status. This thread means a separate path of execution. So this thread can enter anytime into running status, even though this guy is waiting. See, this statement was executed by your main thread. So you can ask the main thread to wait until this guy has completed, but you are not asking second thread to wait until FTE has completed.
Can we interchange them?
Sorry? No issues. If you interchange also, it will be going to execute. See, you have started, right? Starting means the separate call stack has got created. Once a separate call stack has created, those three are available in runnable status now.
Now we have 3 stacks, right?
Oh yeah, that's what. We have 3 stacks available. We have 3 stacks available, and you are asking main thread to join at the end of call stack of child thread. But you are not, let us write one more diagram. See, this is your second child thread. This is your second child thread, and it also consists of a run method. Even though if it is calling the same method code, but still it has created a separate call stack and separate object on the memory. Once it has a separate call stack, now you have 3 call stacks available, and your main thread you are asking to join at the end of this one. And once it has finished, you have specified to join at the end of this one. But between these two, there is no interaction, and these two are running parallelly in the JVM. So your thread scheduler can choose any of these 2 call stacks and execute the program. Is that fine, Adil?
Yes, it is. Thank you. But I just had one sidetrack question. If you basically go to your task manager,
okay,
and basically I need to know how many CPUs are effectively in use at this point. So
only one. Your Java W is the only one will get created as a separate process. When you create a separate thread, a thread is nothing but a separate path of execution which is available under the same heap memory. It won't create, sorry, I have closed. It won't create a separate address space. It will use the same address space for executing different threads.
Right. But I'm just, if you go to the task manager and the actual CPU, for instance, if you go to performance, the tab, all right. So basically, in this particular case, it shows that it's using 2 separate processes at this point on the CPU.
That is because of my dual core machine, right?
Exactly. So, I mean, what I'm trying to understand is when Java is looking at multi-threading, is it looking per CPU, or does it it doesn't really consider the CPU in general?
No, it won't consider.
Okay.
Yeah. See, within the same address space, it will create multiple threads. In the sense, even though if you create any number of threads, even though if you create 10 number of threads, it will use the same memory space, which is 512 MB.
Okay. And then that particular size grows or shrinks as and when it's needed.
No, that's like configurable parameter, and you can set the parameter as a minimum and maximum value, and based on the usage, it can switch from, it can configure or it can use the memory space. Let us say you have specified the minimum of 128 MB, maximum of 1 GB. So it will start using from 128 MB, a minimum, and then it will create the objects 256, 300, 500, 600, and it can grow up to 1024 only because you have specified the maximum value as 1 GB.
And this we are talking strictly with the heap memory.
Exactly. Yeah.
Okay. All right. Thank you.
Yeah. So let us go and change the code in such a way like once after printing a value, I want the current thread to sleep for a second. I'm not going to write any additional statements. So once after printing a value, I'm asking the thread to sleep for a second. So here also I'll specify the name value. Let us go and execute the program now. What happened now? Your child thread, first child thread has started. First thread printing I value 0. So it has printed this particular statement. Once after that, your second child thread has created, and it has also entered into run method, and it has executed this statement, and it has also executed printing I value as 0. Now it has entered into sleeping status. So when the first thread has completed the statement printing I value as 0, there is a statement sleep method, in which case it enters into blocked or waiting status. Anyway, your main thread was available in runnable status. You have mentioned that join at the end of my call stack. So that means thread scheduler can't use that particular thread to enter into running status. And there is only one thread available now to enter into running status, which is your second thread. So now your second thread has entered into running status, and it has printed the statements child thread information, second thread, and second thread printing. And it has also entered into sleeping status. By the time it has entered, probably you can assume that 1 second has completed and it was shifted to this place. Now it has shifted to this place, and by the time it is again waiting for the second time, your second thread has jumped into runnable and it has completed the cyclic order. So you can see that your first thread and second thread are executing simultaneously one by one. But again, this is also not for sure. All the time we can't expect in the same way. But as you can see, 1 second waiting means it's a lot. The total execution of the program, it can complete within a fraction of a second. So 1 second waiting for a thread means it can easily switch the context from one thread to another thread. That's why it was able to print the first and second threads simultaneously. Thread priorities. I'll complete this topic and I'll stop the session, and we'll complete the rest of the topics tomorrow. This is also a small topic only. Thread priorities. When we call thread dot current thread, the second parameter it has printed is related to the thread priority. You've already seen the value as 5. So the thread priority value, it will always be integers. As the name suggests, it might or it can be useful for setting the priority of any thread. You can use set priority of integer or get priority to retrieve a priority of any thread. The values of set priority, it should be between 0 to 10. 0 being the minimum priority, 5 being the default priority, which is normal priority, 10 being the max priority. You can call any thread, or you can use the set priority method for any thread to set the priority. And normally Java spec, it won't suggest to change the priority of any thread. If at all, if you want any thread to be completed first, you should make other threads to sleep for some time, or you can make use of the inter-thread communication kind of stuff, and you can ask the thread to wait for some time, but you are not supposed to follow the priority kind of stuff. And even though if you follow a priority approach, let us say for one thread you have specified that the priority as 10. So when 3 threads has entered into runnable state, let us say the first thread, it is having 10 priority, second thread, it is having 5 priority, third thread, it is having 5 priority, fourth thread, it is having 3 priority. Let us say all these 4 threads are entered into runnable status and waiting for the CPU cycle. The thread scheduler will decide which thread to be entered into running status by looking at the thread priority. So it will find a thread which is having maximum priority, and it will be going to use that particular thread to enter into running status. If a higher priority thread, let us say first thread is having only 8, okay? Let us say the 5th thread has entered now, and it is having the priority of 10, and the thread scheduler is currently executing a thread of priority 8. And let us say it is executing for 5 seconds and it has completed a second now, and it was supposed to execute remaining 4 seconds of code. Meanwhile, 5th thread has entered into runnable status. Then the thread scheduler will verify is there any thread which is having higher priority than the current running thread, and it will immediately move that particular running thread to runnable, and it will make sure that at any point of time only a higher priority thread will be in running status. That is the job will be taken care by your thread scheduler. So at any point of time you can make sure, you can confirm that only a thread with higher priority is in running status. Let us say this thread has completed and this thread also completed. Now second and third threads are available. So between these two, the thread scheduler decides which thread needs to be entered into running status, because these two are having the same priority. But at any point of time, your thread scheduler confirms that a thread with higher priority shouldn't be available in runnable status, and it should be in running status only. It won't consider any threads which are in blocked or waiting status. It will only verify the threads that are available in runnable status. For your current thread also, you can change the priority. Let us say your main thread dot set priority of value 8. So here I'm printing my main thread details. Until now I got the value for main thread as 5. Now I will get the value as 8. You can see that my main thread got the value as 8. If you want, you can change the priority of child thread also. Just go and set the value of child thread, and you can also specify the priorities of child thread as well. Even if you can go to inside your thread running code and you can change the priority. At any point of time, you can change the priority. But as specified, the Java spec won't suggest us to make changes to the thread priority and make it as runnable or running thread based on that. You can make use of sleep method, or you can make use of wait method, which we'll discuss in next class. And you can ask the thread for go and sleep for some time, and at this point of time, your runnable thread can enter into running status. The problem with set priority approach is, let us say you are executing some critical code and some higher priority thread has entered into the runnable status now. So the thread scheduler will follow an approach like no other thread with lower priority is in running status, or no other thread with higher priority is available in runnable status. So that means if you are executing some critical code, it will simply enter into runnable status, and it might not be sure whether the same thread will be chosen once after completing the higher priority thread. So normally this is not a suggestible approach. There are two other topics that we need to complete in threads, which are very important: synchronization, and the next one is inter-thread communication.
So before you just proceed, hi, it's Adil. Just before you proceed, could you go back to the code again? I was just a little confused. So you put the main thread priority as 8, but apparently that has carried forward on the second and the first thread?
Yeah, because you have created child threads from your main thread. So all your child threads by default will get the same priority as of your main thread.
And if you want to change the child threads, you have to do it individually then?
Oh yeah, you can go and change by using the dot set priority method. FT dot set priority of 5 or 6.
Okay. So it's parent to child relationship and
yeah,
all that.
Exactly.
Okay, fair enough. Thank you.
Krish, Soumya here, Krish.
Yes, Soumya.
Krish, actually, it's a doubt outside the topic today. On Eclipse, I just wanted to know.
One second. Sorry. Before that, sorry, Soumya.
No
if you guys have no other doubts, you can leave the class, and we're going to close the session anyway. Yeah. Sorry, Soumya. Go ahead.
Okay. On the Eclipse, Krish, is there a way in which I can see how the control moves step by step?
You can go to debug point. You can put debug points on the right side like this. Just double click. It will place a debug point. And normally you'll click on run button. So instead of that, go and click on debug button next to your run button.
Okay.
When you're trying to execute the program, it will stop at the debug points, and you can take a look at the code, how it is executing.
Okay. And it will show the value of all the variables which are declared in the program till then?
Yeah, it will show you. You can use watch mode, or you can just put your cursor on the variable name. It will show you the data.
Okay. Thank you, Chris. Thanks a lot.
Yeah, you're welcome.
Good night, Chris. See you tomorrow.
See you.
Vish?
Yeah, Vijay.
This is Vijay. Will the class be tomorrow at 7:30 or 8 o'clock?
Yeah, it will be at 8 o'clock only. Anyway, I'll send an email if I want to take somewhat earlier. So just have a look at your emails at 5 o'clock.
Sure.
Okay.
No
Yeah. Thank you.
So much. Good night.
Yeah. Good night.
Chris, this is Rajesh.
Yeah, Rajesh.
In that thread lifecycle diagram,
Mm-hmm.
if you go there,
Yeah.
in the run method, if we use sleep, then from running it will go to the block or waiting state. In the run method, if we write sleep.
Oh yeah. Yeah, and that's what we have written currently.
So after the sleep time is over, won't it come back to the running state, or it goes through notify to the runnable?
No, it will go to runnable status.
So after the sleep time is
whenever
over,
whenever any thread is entered into sleep mode or waiting or block mode, it will be going to enter into runnable state only. It can't enter directly into running state.
Okay, then because this diagram we are showing between runnable and running.
Currently I have specified as notify only, but that is a notify method call which we need to discuss for tomorrow's class.
Okay.
But even though without any call also it will directly enter, because these calls, whatever that I have written, is we can explicitly do, but currently entering from blocker to runnable, it was automatically done by our JVM.
Okay, thank you.
Whatever the method calls I have specified, we can externally make use of them and change the status of the thread.
Okay. Okay, Chris, thank you. Good night.
Yeah, good night.
All right, Krish, have a nice one. I'll see you tomorrow then.
Yeah, see you tomorrow.
Bye.
Okay, guys, I'm also going to close the session. If you guys have any other doubts, just send an email.
many of our students have given testimonials on how our training programs are. You will find them on kudzu.com and on our website h2kinfosys.com. On our website h2kinfosys.com, you will also find more detailed information on who we are, the courses that we offer, what each course covers. Also, if you're interested in a demo program, please register on our homepage on the left-hand side. Just give us more information about yourself and we will send you a link for a demo class. The demo class is absolutely free. Experience our commitment by just attending an orientation workshop at no cost. Our team of faculty and advisors are here to guide you with the right information. If you still have more questions, please feel free to call us. Call us at 770-777-1269. This is a United States number. If you're calling from the UK, call us at 020-337-17615. You can also email us at training@h2kinfosys.com or h2kinfosys@gmail.com. Thank you for watching our videos. We wish you a great career in information technology.